So this question is going to use all of your algebra skills. We're asked to find f composed with g. So that definition is the f of the g of x. Now the g of x is, of course, all of this. So we have to substitute that here. I'd like you to pause your video and do only the substitution for the next step. Did you get this? All of this 4 over x minus 1 had to go where this x was. And that's what we've done here. So now if you think back to week 1 where we talked about complex rational expressions, that's what we have here. Do you remember how to simplify them? I'll let you go ahead and do so. If you remember, we said to bracket the numerator and the denominator and to write this as a horizontal division question. Inside the bracket, I don't need a bracket around 1 any longer. We need to write these two terms over a common denominator, which in this case will be x minus 1. Finish this up. So you should have finished with a composite function x minus 1 all over 6 minus 2x. And now we're asking for the domain of our composite function. It's easy if I look at the very last step here. I see that I have a rational expression, and I know that the denominator cannot equal 0. So it's obvious that x cannot equal 3. However, we also need to go back to the start of our expression and look here. Oh, I'm going to do that with my red pen. You should do this with your red pen as well. Check for restrictions. Because I see that I have this x minus 1 that cannot equal 0, so x cannot equal 1 either. If I substituted a 1 in at the beginning of this equation, at the beginning of this composite function, we would have an expression that's undefined. So we have two restrictions, and if we put those on a number line, 1 and 3, I can see that I have 3 intervals. From negative infinity to 1, from 1 to 3, and from 3 to infinity. So you need to check in 2 places, at the end and the beginning. I've tried to write that down as some steps that you can follow here. If you're given a composite function, f composed with g of x, you first need to find the domain restrictions for g. So whatever the second function is, you need to find those domain restrictions. Then you can find f composed with g and find the domain restrictions for that composite function. You're finding restrictions in 2 places. You're finding restrictions here and here. So the restrictions found at the beginning and the end are the restrictions of your composite function. Let's try that again for the second question, or this example we have here. This time we're finding f composed with f. So f of x. We're changing all of this to the function. And now we're substituting the function into x. See if you can find that composite function. First thing you should do is check the final composite function. Did you get that? And if not, check your substitution. Did you put in the function in the correct way? Did you remember the +2? And then, of course, simplifying those complex rational expressions, you should know how to do by now. Can you find the domain restrictions here? You should have found the two restrictions. Of course, you first could find this one here at the end, where 2x plus 5 cannot equal 0. But you also had to go to the beginning of the question, and you see that x cannot equal -2. Write the domain in interval notation. So you used open brackets for the values that x is not permitted to be. Your domain should look like this. Let's try one more question here. We're asked to find g composed with f. So g of the f of x. Our first substitution. The f of x needs to, the f of x needs to go in the brackets. Do the next substitution. Does it look like this? You had to put the 2 over x into each of those x values. Go ahead and simplify this complex rational expression. So you should have an answer that looks like this. Check your steps, make sure everything is fine. And now tell me the domain in interval notation. You checked the beginning and the end of the question. You found there were 2 domain restrictions, and your interval notation should look like this.